number 3, train problem. Two trains are 450 miles apart and will travel the same set of tracks towards each other. Train 1 leaves its station at 7 a.m. and averages 60 miles per hour. Train 2 leaves its station 10 minutes later and averages 50 miles per hour. All right, so let's set up our RTD table. Train 1 and Train 2. Need the rate and the time and the distance for Train 1 and Train 2. All these pretty well follow that same model. All right. Train 1's rate is 60. And Train 2's rate is 50. Train 1's time, well, we don't know. We're going to call that X. And then Train 2 leaves 10 minutes later. Okay, so that's less time. We already know that. So we're going to take Train 1's time, X, minus 10 minutes later. Well, our time is in hours, miles per hour. So time here is in hours. So we need to convert that 10 minutes to how many hours? Well, to go from minutes to hours, you divide by 60. 10 divided by 60, that goes here. That's 1/6. Reduce that down. So it's X minus a 1/6 of an hour for Train 2's time. Distance now, well, distance is rate times time, so I take each rate times each time. 60x. Rate times time, so it would be 50 times x minus a 1/6. Now we set them up into an equation. Well, we saw that on problem number 1 we added the two distances. Problem number 2 we set the two distances equal. What do we got here? Well, in this case, got a little different scenario. They're traveling towards each other. So here's Train 1, here's Train 2 traveling towards each other. So Train 1's coming, Train 2's coming this way. So at some point, yeah, they're going to meet up. We want to know when that is, and we know that this distance between them is 450 miles total. Well, when they meet up, Train 1's distance, Train 2's distance is here. That's going to be the total distance of 450. So the two will have traveled the total distance of 450. So here's again one. I'm going to add the two distances together. So I'm going to do 60 x, distance 1, plus the distance of the other. Start a little bit lower here. So I'm going to take 60x plus the other distance, the 50, times the x minus a 6, and that's going to be equal to the 450. There's our equation. Now if we can figure out what that equation works out to be, hey, we got it. All right. So we're going to have to solve that equation. 60x, distribute the 50. Apply the 50 in there, so it'll be 50x. 50 times 1/6. That'll be a minus 50 over 6. Apply those together. And that's going to equal 450. Now say 50 over 6. Let's see what that is as a decimal there. 8.33. So let's change that 50 over 6. Let's just go ahead and go with 8.33. 50 times 1/6 is 8.33. Okay, so I've got 60x and 50x. I can add those two together. 110x minus 8.33 add the 8.33. So I'm going to have 110x on the left equals 458.33. Okay? All right, well, let's move our work up a little bit here. So we got 110x equals 458.33. So I'm going to divide by 110 and get my x. So that's going to be about 4.17. And again, x is the time, so that's in hours. Let's see what it asks. How long will train 2 travel before meeting train 1? So I'm wanting train 2's time, so that's x minus 1/6. Right, going back to the table there, right? X minus 1/6, that's train 2's time. All right, so I need to take the x, the 4.17, minus 1/6, and that's going to wind up being about 4 hours. And that should, yeah, so that's our answer there. 4 hours. Okay? We got one more distance problem, number 4. When Michael drives his car to work, the trip takes 0.5 an hour. When he rides the bus, it takes 0.75 an hour. The average speed of the bus is 12 miles per hour, less than his speed when driving. Find his speed when he drives to work and when he rides the bus. All right, well, let's see. Information here we've got. This is a little different because we're trying to find the rate. Whereas before we're finding times. All right, so he's going to ride the bus, going to drive his car. Okay, so let's just, let's call it car and bus. So the car, time, rate, and the bus. Rate, time, and distance. R, T, and D. Okay. All right, so let's get this here plugged in. He rides a bus. It takes, trip takes half an hour. That's the time, 0.5 of an hour. What about the rate when he drives the car? Well, we don't know. Rate is the x, so that one's a little different than the first 3. The x is my rate. The bus, well, the bus, it says when he rides a bus it takes 0.75 of an hour, so that's the time of the bus. It's the bus, and the average speed of the bus is 12 miles per hour less than the speed of when driving the car. So let's write that. How would we write that? Well, the speed of the car is x, 12 miles per hour less would be x minus 12. So those are our rates and our times. Distance, rate times time. So we multiply the rate times the time. 0.5 times x on the top for the car. X minus 12 times 0.75. Let's do it this way right here. Okay? All right. Now, how are we going to set those up as an equation? Well, he's driving his car to work or he's riding the bus to work. Both cases, going from home to work. So he drives the car, he goes, here's his home, here's to work. Driving the car, here. Takes the bus, home to work. That's the distance he travels there. What's the deal here? Well, we've got same distance, don't we? We've got from home to work in both cases, so their distances are equal, so that's our equation. The two distances are equal, so we set the 0.5x equal, or 0.5x, equal to the 0.75 times x minus 12. So this one, another example here of when we set them equal, going the same distance, so they're equal. Solve that out. All right. Well, to solve it out, we're going to have to keep the left side the same, but we're going to have to distribute this 0.75. So we have 0.75x minus 0.75 times 12. It's 9. The x is on one side, so subtract the 0.75x. 0.5 minus 0.75. Negative 0.25x equals negative 9. So we divide by negative 0.25. That gets us x equals 36. So if we answer the question, find his speed when he drives to work. Well, he drives to work, it's x, so that's 36, and the rate would be miles per hour. And when he rides the bus, the rate is x minus 12. So that would be 36 minus 12, that's 24 miles per hour riding the bus. And I guess I should have called this one 36 miles per hour driving to work. Make that correction there. Okay. All right. Now let's change gears here a little bit. On this other page here, we've got a couple of angle problems. So that was the other part of this section that we wanted to talk about, finding the angles, certain angles. All right, number 5 here, we've got to find the measure of two angles, and they are going to form a right angle. All right, so we've got a right angle here, meaning right angle means 90 degrees, right? Got a 90-degree angle, so these two in combination make a 90-degree angle. Well, that's that right there is the equation, isn't it? These two add together to be the right angle, the 90, so that's our equation. We take x, the angle top there, plus the x plus 20 angle. That equals 90, and that sets us up a nice, nifty little equation. Solve that out. You got x plus x. Well, that's both of those have an understood 1 there. 1x plus 1x, so that's 2x plus 20 equals 90. Subtract the 20. So we have 2x is 70. Divide by 2. And we do have x is 35, which is the measure of the top angle, 35 degrees. Bottom angle, well, that would be x plus 20. So I have to just take that value for x, plug in 35 for x, and get 55. So we've got a 35 and a 55 degree angle in that case. All right. One more of these angle problems. Find the measure of each angle in the triangle below. Now we've got triangle and we know expressions for each of the angles. What do we know about that? Well, the key to solving this one is, to realize or to know that anytime you have the angles of a triangle, they add up to be 180 degrees. Should say the sum of the angles of a triangle. Okay? All right, so there's our yeah, that will always hold no matter what size. This triangle looks like this, or if you have a tall, skinny one, short, wide one. Doesn't matter. Always the sum of the angles of a triangle. Well, that means, yeah, you take the three angles, add them together. So we're going to take the x minus 1 angle plus x plus 60 angle, and add to that 2x plus 5 angle, and that's going to equal 180 degrees. There's our equation. Add the three angles, equal them to 180 in this case. All right, well, what do we got? We got an x here, x, 2x, like terms, so add those together, 1x, and 2x, that's 4x. Then we've got minus 1, 60, and 5, so that's, what is that, 59 and 5, 64. Let me combine those constant terms, and that equals 180. Subtract the 64 from both sides, and we get 4x. That equals 116. Divide off the 4, and we have x equals 29. So we want to find each angle, so that's x minus 1 is this lower left one. So that would be 29 minus 1 would be 28. The lower right one would be 2x plus 5. That's 2 times 29, 58, plus 5 is 63. And then last but not least, we got the x plus 60. X is 29, so it'll be 89. All those are degrees. So there's our three little angles.